back over some things because this is something we talked about. It was a couple units ago. But looking at a graph to figure out the number of solutions. Now, this lets us see when we go to use the quadratic formula how many answers we're going to get besides the number of answers we get. We may get one, we may get two, we may get none. It depends. So when we're trying to figure out the number of solutions, basically what we're going to do is try and figure out the number of times a graph crosses the x-axis. So when it says the number of solutions, it's really asking the question, how many x-intercepts are there? How many times does my graph cross the x-axis? And we're not necessarily always going to be looking for the exact solutions. We're just going to be looking for the number of them. And if we don't have a graph sometime, there's even going to be a way that we can figure out just how many solutions there are and not what they exactly are. So like for instance, in number 2, how many solutions are there? How many times that graph crossed the x-axis? Just one right there. And sometimes knowing the number of solutions can be as important or give us as much information as actually knowing what the numbers are going to be. What about number 3? How many times do we cross the x-axis? I thought I heard it. I was going to say 2. And we're going to talk here in a moment about figuring out why that is, why that's the case. So today, and I'm just going to give you an intro to this. We're actually going to get into it a little bit more tomorrow, but I wanted to give you a little bit of a preview on what's going on. So what we're doing, gentlemen, again, I appreciate it. Thank you. So this quadratic formula, this big ugly looking thing here, can be used to figure out what the actual solutions are to things. So I do want to make note of one thing though. This piece inside the radical here, this b squared minus 4ac, is called the discriminant. And if I don't have a picture, this part tells me the number of solutions there's going to be. And we're going to get into that tomorrow on figuring out, okay, so I do this b squared minus 4ac thing and it'll tell me how many, sort of like the graphs did up above. But for today, I just wanted to get a little bit of practice, just a little bit, with plugging in these numbers. So when we're doing these, all we basically do is go, okay, I look for my numbers that are in front of my x squared, and if I don't see one, it's 1. My x, and if I don't see one, it's 1. And my constant term here on the end, and I got to watch the sign too. The sign does make a difference. And all I'm going to do then is plug it into this formula. Now, here's the part that gets a little crazy. So the formula is up here. So I'm like, okay, so negative, my b value is 1. The square root of b squared. Always put your b value in parentheses. Okay, whether it's a positive or a negative, it's just a good idea because that way if it is a negative, you're not going to get a screwed up answer sometime. Minus 4 times a times c all over 2 times a. Now, unfortunately, I would not suggest trying to type all of this into the calculator at once. Here's why. A lot of times when you go to plug this in, all the parentheses kind of mess things up. So here's my suggestion. I would take care of that discriminant part that we talked about first. I would just type in this part at the start. And I wouldn't even do that with the radical. I would just do 1 squared, and if you can do it off the top of your head, hey, that's cool. But if not, no big deal. So what I would do then is then I'd get it into a point where I can do something. Now, Do we know what the square root of 25 is? 5. So really then, once I cleaned this up, -1 plus or minus 5 over 3. And I'm not quite done. I'm almost done. I got one step to go here. It's that plus minus thing that I have to play with. I go, okay, so I've got -1 plus 5 divided by 3, because that's part of it. And then -1 minus 5, because I got to do both of these, divided by 3. And then I just get the answers for that, and I'm done. Now, are they always going to be pretty? No. Sometimes they may be. Oops, forgot my division sign. And I don't care if you go to a decimal. Now, if you did like math, enter, and got 4/3, I'm okay with 4/3 too. I couldn't care less. It's fine. As long as we get to some version of the answer. Oops. So it's not going to get real complex with this. It's just going to be kind of fighting our way through. So I want to do one more of these. I know, I'm going to leave you the big, huge job of doing 2 of them. I'm going to do 2 with you, I'll have you do 2. There's one that has a catch, though, and that's the one I want to do, number 17. Let me bring this down just a little bit. This reminder is what's going to happen here. You must write the equation in standard form. In other words, this has to be on the other side. I have to have this equal 0. So how do I move a positive 25 to the other side? What's the opposite of a positive 25? Subtract it, or a minus, or a negative. So I've got 7x squared minus 2x minus 25 equals 0. Now I can do everything. Now I can see, okay, my a value is 7, because it's the number in front of x squared. My b value is -2. And my c value is -25. And I'm just going to plug those in to my formula, to my, let's see if I can get it, there we go. So, no, now be careful. Negative b, or the opposite of b. Well, the opposite of -2 is +2. And then we have b squared, again, use the parentheses, minus 4ac all over 2 times a. So the big thing here is just making sure that I copy it well so I don't run myself into too much trouble. Once I've done that, again, I'm going to clean up what's inside the radical. But again, I'm not doing it with the radical because there's too many parenthesis problems I can run into. So I've got -2 squared, 4 times 7 times -25, 704. Ooh. Square root of 704. I don't think this is going to turn out nice. It's not. So here's what we'll do with this. Since it doesn't turn out nice, we're going to break this up right away so we're not rounding multiple times. Bless you. And the reason I'm not using the decimal right away, I'm going to in a minute, is that if I round now and then I divide it and I round again, now I'm getting way off from my answer. So here's how I'm going to handle it instead. Now again, this is just my way. I personally would do this and then I'd hit enter. You're like, why don't you just hit divide by 14? Because if I do right now, it's going to do the square root divided by 14 and then add 2. That's not what I want. So I'm going to hit enter, and I'll show you another way you can do this too. And divide by 14. And again, we don't have to go to all those decimal places. Like 2.04 is fine. Well, what if I want to do it all at once? What if I don't want to do all these multiple steps like you do? Because it just confuses me. Okay, if that's the case, all I have to do is put the top into parentheses. Except I have to put another one on there now, because the first one's just to close this, and then the second one actually closes that in completeness for me. And I get my other answer. But like I said, this is letting us get values we wouldn't be able to get by factoring. But it gives us the opportunity to be able to get solutions still, even if we can't factor it. So your job is to get the other two done. So nothing too shabby, not too bad of a task to deal with. Because I wanted to spend a little bit of time today, because we've got one quiz and one test left. Tomorrow is going to be our last quiz. So what we're going to do is we're going to sort of blend some things in here together. We're going to blend in some of our factoring. We're going to do some other things via solving and kind of just see how it works. I wanted to work through this one together with you, just so you've got something that looks good, works well, it's all good. All right, but back to multiplying. We're going to start bringing in some stuff for the final review here a little bit. Here's the kicker with this. Multiply, we've done this two ways. We've done it one way where we just do the lines like you do traditionally, where you say, okay, there's the first ones, x squared next to the first, I add my exponents, okay, x to the third. And then I do the outer ones, x squared times 8 is 8x squared. And then I do the inner ones, negative 5 times x is negative 5x. And then I do the last ones, negative 5 times 8 is negative 40. And if I do it the right way, that little guy with the smile ends up showing up, and I make sure I've gotten everything. I don't have any like terms that are together because they all have different exponents on the variable. So I'm just done. Okay. Now some of you look at all those lines and go, that's just going to confuse me. I'm not going to be able to keep track of this. Okay, here was our other option then. Our other option that we talked about before was making a box that kind of neatens things up a little bit. And both of these ways will get you to the right answer. So if there's one way you like, just do that way. You don't have to do both. And I just put the values outside the little boxes. And what this does for me is it organizes all the pieces for me, and then I just fill in the boxes and I'm basically done. So I go through here, I go, okay. So I got 3, 1 plus 2 gives me x to the third, because I'm multiplying to fill the box up. X times 7 is 7x. 4 times 3 is 12x squared, because I still have to pay attention to my exponents. And 7 times 4 is 28. Now, I can't just leave it in the box. I still have to write it out. But I just find the things, and I write it from the largest to the smallest exponent. I go in degree order. 3, 2, 1, none. And I'm set. You're like, now why are we going back and doing this? Because it allows us to see some of the things that happen when we group or when we factor, how they kind of go together. And this is something we've done earlier, and it's kind of working for us now. Radical stuff. We've done this. Okay. My job. Get x alone. Okay. Where's my x squared? What's my first step to get that alone? How do I get that plus 8 out of there? Minus it. Exactly. Now here comes the moment of truth. How do I get rid of squared? Square root it. And there's one additional piece to this that sometimes people forget. A lot of people just go, okay, x equals 7. They'll go on to the next problem. Then they get a partial credit. They're like, wait a minute. Square root of 49 is 7. That's true. But remember, x squared means there's going to be two answers. So if I just get a plain number like this, I've got to remember that not only is positive 7 squared equal 49, but so does negative 7 squared. So I have to have them both. So those little things can get us sometimes if we're not careful. Now, will they always come out nice like that? No. Like here, for instance, I want to get rid of the squared. You're like, okay, well, we got a square root. And all sorts of things that can get me here. The squared and the square root can cancel. Okay, square root of 100 is 10, but remember, squared. There's two answers to this. I got to get the plus minus in there. Whenever I got to use the square root to get to an answer, we got to do plus minus. So you're like, okay, but then what do I do with the 6? Because I know I'm supposed to add that over. So how's this work? Well, here's how it works. 6 plus or minus 10. And since it comes out nice, I don't have any radicals or anything, I'm actually going to go ahead and get the two answers. Just break it up into 2. 6 plus 10 is 16. 6 minus 10 is negative 4. And we're set. Now, number 5, I'm actually going to leave for you to do in a little bit because it lets us use the quadratic formula. Now, how do you know that? Because if I tried to factor it, I wasn't going to be able to. So we'll come back to him since we've just gotten some practice there with that. I want to keep up with some of the stuff that's going to be on this quiz tomorrow. All right, factoring by grouping. I'm going to do number 6 and 8 with you here to get started, and then I'm going to let you do some of these too on your own. Anytime it says we're going to factor by grouping, we're going to go ahead and just pair them off. Normally you see 4 terms and it's basically telling you as much. So when I'm doing these, what do you think? So we'll cover the second one up here. What do those first 2 terms have in common I can pull out? Yes? A little more? What's the smallest exponent you see on an x? 2, because I got x to the third and x squared. I don't have any plain x's, so I got to get the squared out of there. That's my biggest one. Bless you. So once I do that, I'm at x squared. I need to get to x to the third. What do I need to put here first? Just x. Or you can put a first there if you want to. And then I look at the second one. I'm like, ooh, I already got the x squared. I just need the 4. Now remember our hint from before. If we do this right, our second one should be that way, unless I've done something goofy. But I think I got this one. So I forget about this guy for a minute. Say, okay, what do the second 2 terms have in common? Divisible by 2. Now let's see if things worked out this time. I already got the 2, I just need the x. 2 times what gets me to 8? That's 4. Bingo. I got the same set of parentheses there, and that's what I'm hoping for. Because then my answer is just to copy the in common set of parentheses called a quantity, and then I take those other 2 pieces and get those. And that's how this works. Okay, one more just to be sure. Again, once you get them paired off, cover those guys up. What do those first 2 terms in my first set of parentheses have in common? Couple of things this time. Either part first. I don't care if it's the variable or the number. Okay, so we got a 7 x squared. Perfect. So then I've already got the 7. I got 2 of them. I need to get to 3, so I need 1 more. 7 times what gets me to 28? 4. And I already got the x squared part. So I'm ready to switch this around. So what do those last 2 terms have in common? 3. And let's see, I will write this down. Let's see if it works. 3 times x is 3x, yes. 3 times 4 is 12. Awesome. And then it's just the common quantity, the common set of parentheses. And I'm set. That's how grouping works. Pair them off, take out the biggest thing, and hope that what's in the parentheses is the same. Because if it's not, I need to go fix something. One more flipperooski here, so stay with me. There will be time to get back and get to some of these. Then down here on the bottom part, about halfway down in the back, just a few reminders to get us ready for our quiz. When we factor, again, sort of like what we just did with the grouping. We have the pairs. We find what they have in common. I can get a 4 here. Maybe some of you thought 2. 2 also would work. We could get that out of there. They each have an x, so I can take the x out. And again, once I do that, whatever's left over, since we're doing the distributive property backwards, I already got the 4. I already got one of the x's, but I need 2. Second part, 4 times what gets me to 12? That's 3. And I already have the x's. And I'm factored. There's nothing else to compare it to. There's nothing to solve. It's just factoring it and getting it done, and then we're ready to go. Well, what if they're already factored? And it says solve. Okay. Anything that has x, even if it's just the 2x out there, anything that has x gets set equal to 0. And then we just solve the little mini equations. Like, okay, so here, well, shoot, let's divide by 2. 0 divided by anything is still 0, so okay, I got that part. And then since it's x minus 8, I just do the opposite. Get my 2 answers, move on. What if there's 2 sets of parentheses? I do the same thing. Now, these are a little longer. Now they're 2-step equations, but they're still not anything that we're not capable of. I do my opposites on each of those. And then just do my division. Whoops, that's not going to work. That's better. And again, if it doesn't come out nice, I don't care if you go to a decimal, but I just as soon you just leave it as the fraction and call it good. So we had part where we just factored, part where we just solved. We've been doing the diamonds, okay? Now we get to the factor then solve. We take the 2 sections and we put them together to kind of see how this works. So if I do that, I go, okay, let's do number 10. That looks like the biggest, baddest one. What divides into both 6 and 27? It's a number smaller than the 6. 3. And I also can take an x since they both have one. So at this point I go, okay, 3 times what gets me to 6? That'd be 2. X times what gets to x squared? Well, that'd be x. because 1 plus 1 is 2. 3 times 9 gets me to 27, and I already have the x. So I've done the factoring part like we did up here in the first step, but since the equal 0 is here, whoa. Now I have to set each of those parts equal to 0. And I'm going to get my 2 answers, and sometimes, like I said, they'll come out really nice. And sometimes, well, not so much. But again, this sheet kind of gets us more ready for the quiz. Those other 2 problems on the quadratic formula just get us ready for that. If you get either of them set here in the next 20 minutes, go ahead and get them in. Tomorrow we'll do the quiz and we'll work a little more with the discriminant and the quadratic formula. We'll just kind of keep going sheet by sheet, day by day here, trying to get us ready for the end of the year.